Welcome to video 9. This is about queuing management. Sorry, I have to have light. So you can see what is on the screen. Right, you remember this from the lessons. Okay, queuing management. The most important thing in queuing management is that you correctly identify the model. If you don't identify the model, the proper model, everything will be wrong. All right? So we have this table with so much information. And the first time that you saw this table, you said, "Oh, because this is too much, no? Because I need to know about it." No? We have these 4 models. Model 1, the layout is single channel, service phase single, source of population infinite. And we say infinite even though we know that populations are not infinite, but infinite it means that you can never know how many people can arrive. This is a big airport, a shop in a big city, a warehouse. When you don't know the number of units, people, customers, patients that can come, and you know that this number can be really big, right? The arrival pattern has a random component, so it's Poisson Markov. The queue discipline is first come, first served. The service pattern is exponential. Exponential means that there is a randomness as well in here because this means that there is a human being rendering this service, okay, or doing this work. This means that you can prepare 100 coffees in one day if you are a waiter, but it won't take exactly the same time to prepare each one of these coffees. Then we have the permissible queue length, unlimited, and an example of this is a one-line toll with a human being, okay, in which you pay for driving your car on a highway, all right? Then the other models have very similar characteristics, but to be able to identify the model, the most practical thing is to detect the differences between any model and model 1. So if you know the characteristics of model 1, and then you compare to the following model, for instance, model 2, the only difference between model 2 and model 1 is that the service pattern is constant. In model 1 is exponential, so a human being. In model 2 is constant, so a machine, a perfect machine, right? All the rest of the characteristics are the same, and the example is different. A Dragon Khan is a machine, it takes the same time to do all the way, okay? Model 3, the only difference between model 3 and model 1, so we always compare to model 1, okay? The only difference between Model 3 and Model 1 is that Model 3 is multi-channel. So we have more than one server. And it's a human being, okay? Because this is the only difference with Model 1. In Model 1 we have a human being, so in Model 3 we have a human being as well. All right? And the only difference between Model 4 and Model 1 is that the population is finite. It's not infinite, it's finite. The example of this is, the example that I gave you in class, is the number of computers that we have at UPF. So the person who's in charge of the maintenance of these computers knows exactly how many computers we have at UPF, right? So the only thing that you need to do is know very well the model 1 and then compare the other models to model 1, and that way you decide which is the right model to use for each occasion, right? So let's forget about this for a moment. And I leave the LQ table here ready to use because we will need it later, okay? And now we'll do an exercise about a warehouse. There's many different things. It's called the big warehouse, right? We have only one worker, even it's a big warehouse. No? Only one worker. S, key, is 1, okay? Number of channels, 1. It's a worker, it's not a machine. I'm giving you some leads to know what model is this. No? So this is a big warehouse in a big town. So we could say that the population is infinite. There is one worker, human being, so this is not model 2. Population infinite. is not model 4, and now it can be model 1 or model 3. We said there is only one worker, then it's not model 3, so it must be model 1. Okay? All right, we have this situation. The arrival rate is 1 client every 20 minutes, and the service rate is 1 client every 24 minutes. We like to express this rate in units per hour, or clients per hour in this case. So in this case, we will say that this is 1 client every 20 minutes, 60 minutes, 1 hour, and we'll have that this is 3 clients per hour, right? And in this case, we have 1 client every 24 minutes, divided by 60 minutes, 1 hour, and this will give us, I don't know it, nobody. The calculator is at home, so I will use this. 2.5. 2.5 clients per hour. All right? So the arrival rate, remember, lambda, is 3 clients per hour. And the service rate is 2.5 clients per hour. And now that we determine that this is model 1, the following thing that we have to do, we heard about some problems in the warehouse. Some clients are complaining. Some clients go to somewhere else because they are not happy with the level of service here. Which can be the reason? Well, let's work out the ratio of utilization rho. This is lambda divided by mu, and we'll see that 3 divided by 2.5 is more than 1. Okay? How much is it? We don't know how much it is, but by now we know that this is more than 1, and this means, this means problems. 1.2. Okay? 1.2. When the ratio of utilization is equal or more than 1, in model 1 and 2, this means perpetual queue. In model 4, we don't say anything because we don't use the model 4. If it's model 3, it doesn't necessarily mean perpetual queue, but in model 1 and model 2, this means perpetual queue. In this case, we are suffering a perpetual queue, but it means that the queue is longer. We open in the morning, we don't have a queue, maybe after some minutes we have a little queue, and this queue is getting longer and longer and longer as time goes by, and customers complain, and customers go somewhere else, so we lose sales. So we should make a decision, okay? Remember, when we have this perpetual queue situation, even though we know that it's model 1, and now we could take the equations from model 1, it's a nonsense. These equations don't work when there is a perpetual queue. You will get very strange results, like a negative result, or that you have to divide by 0, and this is absurd, okay? So when it's model 1, or model 2, in this case model 1, and you have a perpetual queue, you stop it here. You say, no, I cannot go on, I cannot work out LS, LQ, no, because there is a perpetual queue. So what you have to do is to make a decision to improve this situation, right? So we'll see this in the following video.